5 seconds left. Okay. Welcome back, guys. So, yeah, I think the first thing we're going to do is go through this real quick. And for anyone new to the stream, essentially, at the start of every stream, as long as I have it prepared, I like to go over one, like, common Leetcode question. And then I usually make a nice little YouTube video out of it. I've only done it like 3 times or 2 times at this point, but, you know, I'm trying to actually get that going. Because right now my YouTube channel only has like 3 videos on it. And yeah, I think it'd be a cool series. It helps me, helps you guys, and also put some content for not only the stream and the YouTube channel. Okay, so during these, I go to an overlay that doesn't have chat, even though it doesn't work anyways, but it doesn't have like the follow notifications and stuff, and I usually turn the music off because it's not the best. It doesn't really fit the vibe of a tutorial a tutorial video. Okay. Hey guys, it's Katie. Fuck. Good start. Can't even do the first sentence. Alright, it's Caden Codes here, and today I'm going to be going over the Leetcode question, longest palindromic substring. So basically, given a string S, we want to return the longest palindromic substring in S. So a palindrome is a word that reads the same backwards as forwards. So an example would be dad. If you put the letters, like reverse the letters, you're going to DAD as well. If you reverse 1221, you still get 1221. And an example like this, you're going to be given a string like BABAD, and the only palindromic substring within here is BAB and ABA. And depending on how your function works, you're either going to return BAB or ABA. They're both valid answers because they're both palindromic strings with the max length inside. So this one is 3, this one is 3, it doesn't matter. But if this one was like BAAB, it would have a length of 4, and we would return that instead. So in a string like this, where we have ABC race car S, race car is a palindrome and it's a substring within the string. So we would return race car. And the methodology we're going to go over today has a time complexity of n squared. So what we're going to do is we're going to expand around each center within the string and check if there's a palindrome on each side of the center. So there's going to be 2n minus 1 centers. And the way to think about this is that, say we have five characters. There's gonna be a center at the character and a center after the character. So there's a center here, there's a center between B and A, there's a center that starts at A center after A, and so on. And the reason we have 2n minus 1 is because the last character, there's no center after it, because you can't have a center with at least 2 characters that involves only 1 character. So the way this is going to work is we're going to loop through each center. So say, for example, we have A. What we're going to do is check on each side with 2 pointers. So say we have like left and right. And we're going to move them over one by one. And we're only going to continue moving them until either we find 2 characters that don't match, or the pointer hits like the start of the string or the end of the string. So in this example, we'd start at A. We go, all right, we're going to move our pointer 1 to the left and a pointer 1 to the right, so we're going to have 2 pointers. And we see that B and B are equal. And then on the next go around, we would move the left pointer to the left, and we would see that it would hit -1. So we would stop the substring there. We would take a look at the substring we just formed and check the length of it. And then we're going to update our max string as we go through this. So we're going to do this for every single center within the string. And another example of this is, say you have a center between 2 characters. It starts by checking the characters on each side of it and slowly expanding that out until it finds either the start of the string or the end of the string, or it finds 2 characters that don't match. So now we're going to look at the actual programming solution on Leetcode. So I did this in Python 3, and I did this by doing one method here and then also a helper method. So the way this works is that we're going to initialize our palindrome as an empty string. And what we're going to do is loop through each character like we talked about. And what we're doing here in this line is we're going to take the max of... So what we're going to do here is take the max of each palindrome at 2 centers that we're going to check for each character. So like we talked about, there's 2 characters for every me try to explain that better. So what we're going to do is get the palindrome at the character we're looping over, and then also the space between this character and the next character. And we're going to compare them and our current max length to get to continue updating our longest palindrome. So, for example, we would check the character at 0, and then make our center. Okay, I'm sorry. Let me like take a deep breath, I guess. Okay. So we're gonna loop through each character in S, and for each character, we're gonna check a palindrome if the center is at that character and at the space between the current character and the next character. So, like we talked about over here, say we're iterating and we're at A, we're gonna check the palindrome around the center A, and then checking it at the center after A and before the next character, so between A and B. So we're gonna do that for each character in here. And what this helper function does is that it does exactly what we talked about. So it's going to look at our two left and right pointers. So for example, when we're checking if it's just that character, we pass an I and I because our center is going to start at the same spot. But when we're starting at a string where we're between characters, our left pointer is going to start at this Y and our right pointer is going to start at this Y. So we're going to continue to move them over until either left isn't greater than 0 anymore or the right pointer is greater than the string length. And we only continue to move the pointer until the characters are the same or we hit this condition. So each loop we move left 1 to the left and right 1 to the right. And then we return the actual string that we find, the palindromic string that we find from this method. And then what this max function does is that this is going to return a string, this is going to return a string, and this is the current string we have that holds our max palindrome. And with key equals length, it's just comparing the lengths between these two strings and returning the best. So the result of this will end up being the longest palindrome within the string. So for example here, our method actually returns AVA, but VAB is also acceptable. And by submitting this, we can see that it's pretty fast and it has a pretty good memory usage. So it's faster than about 66%. This obviously varies with each run you do, but still pretty good. And then our memory usage is less than 93%, which is very good. And yeah, thanks for watching, guys. Make sure to subscribe if you want to see more videos like this, and have a good day. Okay, we've definitely had better ones of those, but we got through it.